A very good morning. So first we'll start with the questions, unanswered questions. Yesterday, last part of the session, we had few questions, right? So we'll discuss those questions first, and then we'll proceed with the discussion of multiple choice questions pertaining to public health dentistry, right? So first of all, there was one question pertaining to effect of skewness on mean, median and mode. So skewness is nothing but presence of asymmetry. So for example, as I said, in case of normal curve, it is perfectly symmetrical, right? Bilaterally symmetrical, perfectly symmetrical, bell-shaped. But because of variation in mean, median and mode, there can be skewness. In the sense, there can be this non-uniformity, or it's nothing but measure of asymmetry. So I'll just show you some images today as some examples for positive skewness and negative skewness. So as you can see in this image, on the left side, it's written negative skewness. The right image shows positive skewness. It means when the mean value is less than either median or mode. In such cases, we see negative skewness. On the other hand, when the mean value is greater than mean or median, then we call it as positively skewed distribution or positive skewness. So skewness is nothing but lack of symmetry or presence of asymmetry, right? So this skewness is seen because of variation or difference in values in mean, median and mode. In case of a normal distribution, mean, median and mode, they coincide almost at the center, hence there is no skewness, and the normal distribution is symmetrical, right? So to that question, like effect of skewness on mean, median and mode, in case of positively skewed distribution, as is shown in the image, mean is larger than mean, a mode or median. In case of negative skewness, the reverse is true. That is, mean is smaller than median and mode, right? And then coming to the next question, one of you asked me the differences between standard deviation and mean deviation other than the formula. See, mean deviation, it's nothing but we take the average of all the deviations without considering the negative values. Let me just show you the table and then explain you simultaneously. If you observe this table, this is the, these are the diastolic values. These are the mean values, right? And this is the amount of deviation which we are seeing with respect to each variable. For example, these are 10 patients, the values of diastolic blood pressures of 10 patients. So each observation, how much is it deviating from the mean? So that's the difference here. So the deviation from the mean, the average of these deviations from the mean is given by mean deviation. But we are not considering the negative or positive symbols here. I think that's, is it streaming? I think it's streaming, right? 1 second. I think we're having again network issues. Okay, fine. So mean deviation or average deviation is we're trying to obtain how much of deviation is present with respect to each observation and simply the average of these absolute values without considering the positive or negative sign. So that is mean deviation or average deviation. But standard deviation is something where we're trying to square the value and then obtain the root. So as one of you asked me right yesterday, like whether standard deviation is positive or negative. Since we are squaring all the values, if you observe the formula of standard deviation, you'll understand that. So as we discussed yesterday, so this is standard deviation for a sample less than 30, right? So since we are squaring all the deviations or variations, so there won't be any chance for negative values. Since we're squaring, a negative becomes positive, right? We're squaring it and then taking the root of it. So standard deviation values can never ever be negative. They're only positive, right? So that's very important. And moreover, when you compare mean deviation and standard deviation is most commonly used method to evaluate the variability compared to mean deviation. So let me just read out or summarize the differences apart from the formula. Standard deviation, it measures the spread of observations. If you observe this bell-shaped diagram, so it's all about understanding these diagrams. It will be much more simpler and easier. So as you can see here, we have a normal distribution over here, and you can see the mean, and these are the standard deviations, right? First standard deviation, second and third. So these standard deviations give us an idea of the distribution of the observed values, like how they are distributed within this normal curve. So that idea is given by standard deviation. So standard deviation is a measure of spread of observations, whether the observations which we have done fall under the 68% category or a 95% confidence interval or 99% confident interval, right? So the spread of observation, the spread of these observed values is understood based on the standard deviation, right? So standard deviation, it's a measure of spread of observations. If I say confidence interval 1, then obviously you'll understand that the observed values fall under 66% of the total area. If I say confidence limits 95, then it's obviously understood that the observed values fall under 95% of the observed area within the normal curve, right? So, and moreover, as I said, standard deviation is commonly used measure of variability, and standard deviation can never be negative as we are squaring all deviations. So Nidhi, they cannot be negative. Only the z value can be negative. Z value again represents the same, the distance from the mean. I'll explain you that later. So z value can be negative if it is below the mean or left side to the mean in a standard normal curve, and it can be positive when it is right to the mean, right? Good morning, by the way, both of you, Megha and Nidhi. So standard deviation gives us, if you observe the normal distribution curve, you'll have this understanding. So standard deviation gives you an idea regarding the spread of various observations, right? And it can never be negative as we are squaring all the deviations. Just observe the formula. And mean deviation is nothing but it's just an average of all the deviations, absolute deviations, right? Without considering the values, positive or negative, because sometimes the deviation can be negative, right? If for example the mean value is 90 in a test of 100, the mean value is for example 90. If I score 80, then obviously the deviation is -10, right? So those negative values are ignored while calculating mean or average deviation, and only the absolute values are considered, right? So that's these are few differences which I could find out from the sources, that is mean deviation and standard deviation, right? Of all this, standard deviation is considered to be more reliable, okay? And then also we discussed about the effect of skewness on mean, median and mode, right? And then coming to Z-score, Regina asked me yesterday regarding Z-score. So Z-score is nothing but it gives us an idea like how much for example, a particular value, how much distance does it fall from the mean, or in other words, in simple words, Z-score is nothing but the number of standard deviations from the mean. To understand Z-score, let me just give you one illustration. So we have one problem given in part. I'll just go through it, and then we'll come back to the multiple choice discussions, right? Yeah. So Z-score gives us the number of standard deviations from the mean. Okay, Z-score has a range of -3 to +3, because if you observe a normal curve, we have -3 and +3 standard deviations, right? So Z-score is nothing but it gives us the number of standard deviations from the mean. And Z-score can be both positive and negative. If it is left side to the mean, then we have these negative values. If it is right side to the mean, then we have this positive values, right? And the formula to calculate this Z-score, or it's also called as relative deviate or standard normal variate, the formula is x minus x bar, that is observed value minus arithmetic mean divided by standard deviation, that gives the Z-score. And if you observe a table here, in part they have given the areas of standard normal curve with mean 0 and standard deviation 1. So let me just show you that table. You just have a look at this table. So if Z-score is 0, then the area, you can just see the proportion of area from middle of the curve of designated deviation, right? So let me just come back to the curve, right? So this is the mean, right? If I say Z-score is 0, then we are almost at the center, exactly at the center. If Z-score is 1, Z-score is 2, Z-score is 3. So maximum we can have +3 Z-score if it is on right, -3 Z-score if it is on left, right? So Z-score gives us the number of standard deviations from the mean. Let's try to understand that now. So as you can see here, Z-score is 0, the area or the proportion of area from the middle of the curve is 0, because you're almost at the center, right? If Z-score is 0.5, then the area is 0.19. So corresponding to Z-score, we have these areas, right? To understand this table, let me just take one example of Z-score. So let's take, for example, Z-score of 2. So Z-score of 2 is equal to 0.4772, right? So just keep that in mind. Z-score of 2 is equal to 0.4772, 0.47. So now let's come back to this. So Z-score of 0, Z-score of 1 and Z-score of 2. So Z-score of 2 is nothing but 0.47. So this is on one half of the curve. So 0.47 here and 0.47 here accounts to 0.95, or in other words 95%, right? So Z-score of 2 indicates that 0.47 area is being covered on one half of the curve. That's very important. We're not talking about both sides. We're talking about only one side. If Z-score is 2 or if Z-score is -2, then we'll say the other way, right? So when I say Z-score is 2, then it is 0.47 or 47% of the area on one half of this curve, right? Let's try to understand that with an example, right? So I'll just give you one problem as given in part, and then we'll have a discussion, then we'll have better understanding of how we can use this Z-score, right? So estimation of probability. Let us suppose the pulse of a group of normal healthy males was 72, the pulse, with a standard deviation of 2. So what is the probability that a male chosen at random would be found to have a pulse of 80 or more? So they're given us the standard deviation, they're given us the mean value, right? The mean value here is 72, the standard deviation is 2. So from this, if you calculate the Z-score, because for Z-score you need to have the observed value minus the mean value divided by standard deviation. So the question here is, if the mean is 72 and if the standard deviation is 2, what is the probability of a male chosen at random would have a pulse of 80 or more? So observed value, consider that it's 80, right? So 80 minus 72 divided by 2. So just substitute these values in the formula for Z-score. Then the Z-score would be 4, right? Let me just write down. Relative deviate Z-score, Z is minus x bar divided by sigma 80 minus 72 divided by 2. Just observe this value. Okay. So the question is, I'll just read out the question, right? The pulse of a group of normal healthy male was 72 with standard deviation of 2. So what is the probability that a chosen male or a male chosen at random would be found to have a pulse score of 80 or more? So from this, you calculated the Z-score, which is around 4, right? So Z-score which we obtained here is 4. Just keep that in mind. Now, I've shown you one table previously. One of the aspirants also asked the same previously yesterday. So, if the Z-score is 4, then the amount of area that's being covered is 0.49. Just remember this value. Z-score is 4. If the Z-score is 4, then the area that is being covered from towards one side of the curve is 0.49, right? Just keep that in mind, 0.49. Now, the area of normal curve corresponding to a deviate 4 is 0.49, as we have shown in the as we have seen in the table, right? Since we are dealing with 1/2 of total area, so we're talking about 4 in the sense it's plus 4, right? So plus 4 in the sense it is towards the right side of the curve, right? So the total area of the right side of the curve, as I said, the total area of a normal curve is 1, right side will be 0.5, left side will be 0.5. So the area of curve on right side is 0.5. Okay, now since we are dealing with only 1/2 of the total area, the area beyond 0.49 is equal to, right? I'm just trying to draw the diagram also. So as you can see here, since the mean value of the pulse is 72, so what is the probability of finding the individual with a pulse of greater than 80? So we're trying to find out this area, this little area. So we know this area, right? So this entire area, see, from the middle, from the mean, the entire half will be 0.5, the area, right? Since the Z-score is 4, which is nothing but 0.49, so when you subtract the entire area, when you subtract this 0.49 from the entire area, that is 0.5, then you are going to get 0.0003. So this area is nothing but 0.00003 or 3 in 1 lakh individuals. So the probability of finding a male with a pulse of more than 80 is 3 in 1 lakh as per the calculation. If you just observe here, we tried to obtain the Z-score. So Z-score, as I said, gives us the distance from the mean or gives us the number of standard deviations from the mean. So based on this formula, the Z-score is 4. So we are 4 standard deviations away from the mean. So 4 standard deviations means, so the total area is 0.5. 4 standard deviations is 0.49 as shown in that table, right? So 0.5 minus 0.49 gives 0.003. 0.00003. I mean, these values are, it's not just 0.49, right? So it's 0.49997, something like that. So if you subtract the values, you get this 0.00003 or 3 by 1 lakh or 3 in 1 lakh. So the probability of finding a male with a pulse of more than 80 is 3 in 1 lakh. So that's the answer for this question. I mean, if it's confusing, I'll just repeat once again, or if it's fine, we'll just proceed with the next part of this discussion, right? Hi Ramesh, good morning. Good morning Tanmay and Preeti. Yes, Nidhi, you're talking about, yeah, they're saying that the normal curve depends upon the mean and standard deviation. Hi Vishwanath, morning. Hi Sadhana. Now, what is your doubt in that, Nidhi? They're saying that normal curve depends upon the mean because we're constructing a normal curve based on the mean and standard deviation, right? So now we have seen the estimation of probability. So to the question, the pulse of a group of normal healthy male was 72. So the mean value is 72. The standard deviation is 2. What is the probability that a male chosen at random would be found to have a pulse of 80 or more, right? So it's 3 in 1 lakh, and that's how we use this Z-score. Hi Regina, good morning. We're discussing the topic which you have asked just now, right? So we discussed about Z-score and also how to utilize it in order to calculate the probability of finding a particular observation. Third line. For the present, we may contend with the basic significance of standard deviation. I didn't get you, Nidhi. If possible, just quote that, or you can just take a pic and share in our WhatsApp update group. Hi Sneha, glad to hear that. Good morning. Good morning Abhishek. Anyways, I'll try to summarize once again all the introductory part because I started at 5:10. I'm not sure how many of you followed it. So before concluding, I will try to summarize the same. You mean, okay, for the present we may contend with the basic significance of standard deviation. So what he is saying here is, since they've explained about standard deviation measures of dispersion, standard deviation can be better understood only after understanding the normal curve. That's what they mean. So they said it's content. Okay, you just stop here. That's what they're trying to say us to the reader. Just stop here. Just stay content with the amount of information given. We'll discuss about normal curve and then you'll understand standard deviation in much better manner. That's what I understood after reading that. For the present, in the sense, for the present pair or for the previous topic of measures of dispersion, right? Right? Okay, we'll proceed then. And then, what is standard error? We'll also discuss in brief about standard error, and then we'll discuss few multiple choice questions. So standard error. So what is standard error? So standard deviation. So standard error is nothing but the amount of error that's present between the actual mean and sample mean. You understand when I say that? Let's see. It measures the accuracy with which a sample represents a population. In statistics, a sample mean deviates from the actual mean of group of observations, and this deviation is called as standard error. So standard error is calculated by the formula standard deviation divided by root of number of observations. Standard deviation divided by a square root of a number of observations. So let me just give you an illustration so that we can better understand what is standard error. For example, I've seen one video on statistics and they're given this beautiful example. If you're trying to calculate the average age of Indian population, so let's consider this example. So what would be the average age of Indian population? So that's our task as statistician. That's our task now. So what do? We just can't count each person's age and take an average, which would be impossible, right? So we have more than 100 crore population. So what do? We take a sample. We have different types of sampling techniques. Okay, that's beyond the scope for discussion now. So we take a sample which is representative of the entire population. So we have certain criteria for sample selection and all. So in that sample, we'll do some study, we'll take the age, etc., and we'll try to obtain the average age, right? So the sample is representative of the entire population. So whatever result we're getting for that sample, that is the average age which we obtain for that sample, will be extrapolated. Means it will be compared to that of entire population, right? So actually speaking, the average age of the sample which you have taken and the average age of the entire population slightly differs, because you're not taking, or you're not considering all the individuals, right? You're only taking a sample. So the greater the sample size, the smaller the standard error. So I hope it's clear, right? So standard error is nothing but the difference in the average values of the entire observations or the entire population and the sample population. So difference in mean is given by standard error. So the greater the sample size, the minimal the error will be, because the sample size becomes more and more. Obviously you're trying to include a lot many observations in that, so the chances of error or difference between the sample mean and the overall mean will minimize. I hope it's clear, right? So as I said, if you're trying to calculate the mean age or the average age of the Indian population, you take a sample rather than calculating everyone's age, right? So the mean or the average mean or arithmetic mean of the sample population and the arithmetic mean of the entire population slightly differ, right? Because we're taking a small sample or large sample or whatever it is, sample we're not including the entire population, right? So this is small comparatively. So the means do vary. So this difference in means between the sample mean and the mean of the total population is given by standard error. And standard error we calculate using the formula standard deviation divided by square root of number of observations. It means the standard error and the number of observations are inversely proportional, in the sense the larger the number of observations or the larger the sample size, the smaller the standard error is. I hope it's clear, right? So that's pertaining to standard error. And I hope it's streaming live. Yeah, there was some problem in between and it is showing again as poor connection. Okay. I mean, is it fine? Could you follow when I explained you about standard error? Anyways, I'll summarize that before concluding the video. Okay, can you proceed? Okay, fine. Yeah. Now we'll discuss some multiple choice questions for around half an hour, and then I'll once again clarify all the queries, unanswered queries of yesterday's session, right? So before concluding. Now, so I hope it's really clear. If in case you have any queries, you can post them at any time. I'll answer them before concluding the session, right? So as the sample size increases, the standard deviation decreases, increases, remains the same, or may increase or decrease. So what is the relation between standard deviation and sample size? So as one of your, I was asking yesterday, like, do we need to, I think it's Burness, do we need to memorize this formulae? Okay, memorizing the formulae helps us to answer such questions as well. Yeah, so as you all know, standard deviation is given by the formula root of sigma. We have these x1 deviations, right? X minus x bar square divided by number of observations. Everything is being square rooted, right? Yeah, so it is inversely proportional. To understand, or to put that simple, the relation between standard deviation and the number of observations is inversely proportional, as you can see here, right? So this is calculation of standard deviation for sample size less than 30 because it is eta minus 1. So we have sigma summation, right? These are deviations from the mean x minus x bar. So x minus x bar square divided by eta minus 1 square root. Okay, so the relation between the standard deviation and number of observations is inversely proportional. It means the greater the number of observations, the lesser the deviation is. In other words, to understand that simply in layman terms, greater the number of observations means you are trying to include everyone. So the sample which you are taking is representing the entire population for that matter, right? So greater the size of sample, lesser will be the errors, standard error, lesser will be the standard deviation. Just keep that in mind. Okay, yeah, inverse relation. Great. Now, so we have another question pertaining to this coinciding of mean, median and mode. So mean, median and mode coincide in we have this positively skewed distribution, negatively skewed distribution and normal distribution. I hope it will be clear. I mean, you can answer that with ease, right? So mean, median and mode, they coincide in case of a bell-shaped symmetrical curve, that is a normal curve. Whereas in case of positively skewed distribution, so skewness is nothing but, as I mentioned, that's the first question which I discussed today. Skewness is nothing but the measure of asymmetry, right? I hope you have seen those images. Anyways, I'll just project them once again. Okay, so as you can see here, this is negatively skewed. Yeah, this is negatively skewed and this is positively skewed. So in negatively skewed, you can see that the mean value is less than median as well as mode. Whereas in positively skewed, the mean value is greater than median or mode, right? So they can ask you a question pertaining to this. They'll give you some observations, right? So they'll give you some set of observations and they'll ask you whether the distribution is positively skewed or negatively skewed. So for that, you need to calculate the mean and median or mode if possible for that set of observations. And then when you, based on the magnitude of the values, right, whether the mean is less than mode or greater than mode, or mean is less than median or greater than median, then based on that you can say whether that distribution is positively skewed or negatively skewed. We have one question pertaining to that. We'll discuss that later. I hope it's clear, right? So pertaining to skewness, because yesterday one of our aspirants asked the relation between skewness and mean, median and mode. So in negative skewness, mean value is less, whereas in positive skewness, mean value is more, right? Okay. And also, let me just ask you this question. Correlation between height and weight of children is best represented by histogram, line diagram, scatter diagram, and bar diagram. So try answering this question. The correlation between the height and weight of children is best represented by histogram, line diagram, scatter diagram, and bar diagram. So we discussed extensively about these different ways of presenting data. So even we had that question. I mean, one of our aspirants also asked that question on that same day itself. So two variables, the differences or the variations or the relation between two variables can be best demonstrated by scatter diagram. And if the scattering or if the dots are clustering around the central diagonal line, if you observe, if you remember, then the relation between the two variables is linearly proportional, right? Okay, great. Now let's move on to the next one. Yeah, now we have a question for you on standard error. Standard error of mean or standard error indicates so standard error of mean or standard error indicates dispersion, distribution, variation and deviation. So measures of central tendency, mean, median and mode, right? That's clear. Measures of variation are, you have this range, mean deviation or arithmetic deviation, average deviation, and also we have the standard deviation, right? So what does standard error indicate? So also I've explained you about standard error before starting the multiple choice question, so try answering that. Yeah. Pritika, you say D. Okay. Okay, Megha. Deviation. Variation. Hi Isha, glad to hear that, and thank you for the feedback. So maybe you have typed the wrong email ID. You can just check out now. It's proud to be dentist. It's not nothing. Proud to be dentist at gmail.com. You can use that email ID which I've given you. Yeah, Regina, you say distribution. Okay. So standard error gives us the difference or the discrepancy between the sample mean and the overall original mean, the actual mean, we can call it, right? So standard error gives us difference between the sample mean and the actual mean. So it tells us how much of deviation is there in sample mean when compared to the actual mean. So that's standard error. The standard error is given by the formula standard deviation divided by root of number of observations. Okay, anyways, I'll explain you once again, right? What is standard error and all, right? Is it fine? Do you want me to proceed or do you want me to explain that now itself once again? I also gave you an example of calculating the population, right? Yeah. Anyways, we'll proceed with other multiple choice questions, and at the end, during the summary time, we'll have a brief discussion once again. Okay? So, standard error of mean indicates the deviation of the sample mean from the actual mean. Okay? Yeah, so based on this, you can have a question. They can give you some values. For example, we have one question in Pulse where they have mentioned that the sample size is 100, the mean weight is 35, and standard deviation is 2. So what is the standard error of mean? So standard error of mean is given by the formula, as I said, standard deviation divided by square root of number of observations. You substitute these values there, you can answer it. Okay. It's not waste time. Okay, now we have another question. if the mean Yeah, try answering this. Isha, will you be able to help me? I have some questions in radiology. I'll email you. Third trimester. Okay, Isha, definitely. You can drop a mail. You can ask any of your questions or queries. You can drop a mail. I'll definitely reply. Typically within 24 hours, right? Yeah, you have any queries subject related, you can always drop a mail. 24/7 Isha. All the very best. So the question now is, if the mean cholesterol values of a group of normal subjects is 230 milligrams percent with standard deviation of 10, the 95% confidence limits for population are, we have options 220 and 240, 210 and 250, 200 and 260, 210 and 240. So it's nothing but Z-score is 2, or we can say 95% confidence limit means the confidence limits are plus 2 standard deviation. So from the mean, if it is 66%, it is 1 standard deviation on either side. If it is 95%, it is 2 standard deviations on either side. And if it is 99%, it is 3 standard deviations on either side of the mean in a normal curve, right? So if you get that idea in your mind, then you can answer this question with ease. So you have the mean 66%, 1 standard deviation on either side. 95%, 2 standard deviations on either side. 99%, 3 standard deviations on the other side, right? Just observe that Bell diagram, normal curve, it will be clear. Yeah. Since the mean value is 230, since the standard deviation is 10, but the question is 95% confidence limit, which means we have to include 2 standard deviations. So 1 standard deviation is 10, 2 standard deviations will be 20, right? So it will be, the lower limit will be 230 minus 20 because we're considering 2 standard deviations, and the upper limit would be 230 plus 20. Sneha, you would be right when the question is 66% of confidence intervals. But since the question is 95% confidence intervals, we need to subtract 20 and add up 20. If it is 66% confidence interval, then it is subtracting 10 and adding 10. Yeah, great. So since it is 95% confidence limit, right, we need to subtract 2 standard deviations and at the lower limit and add up 2 standard deviations at the upper limit, right? So so to understand that simply, right, you have done one experiment. The mean value of people with cholesterol is 230. So the question is, and the standard deviation is 10. If you are doing on study and you have these observed values 230, 220, 210, 215, so you have done a study on 100 people and you have these 100 values, right? So the chance of finding these observed values within this area, so the 95% chance of finding the value, so between 210 and 250, among all the observed values, as I said, you have done a study on 100 individuals, you have all the values. So between 210 and 250, you will include 95% of the observed values. So that's the inference for this question. So to understand that question in simplified manner, since you have calculated and you have given me the answer 210 to 250, so you have done this study on 100 individuals. For example, you have different values of these cholesterols. So the values between 210 and 250 will be covering around 95% of the observed values. The rest 5% will be either less than 210 or more than 250, right? I hope it's clear. So that's the kind of inference which we can take up. I mean, if you want to analyze it and to understand it in a further simplified manner, that's how we can interpret these results, right? I hope it's clear. Yeah, now assuming that you understood what I explained, I am proceeding with the next question, right? Here we go. A normal distribution curve depends upon mean and sample size, range and sample size, mean and standard deviation, mean and median. So you should be able to answer this with ease, because all these days, 2 or 3 days, we have been discussing about these similar concepts, right? Yeah. Okay. Great. So yes, that's true. It is mean and standard deviation, right? So that's obviously understood. Great. Now let's move on to the next one. Okay. Let me just ask you this question. Which of the following statement is true about standard normal curve? So which among the following statements is true about standard normal curve? It's better if I type it out, right? Yes, yes, Neha. Yes, you're all right. So which statement is true about normal distribution? Mean value 1, standard deviation 0. Standard deviation 1, mean value is 0. Curve is skewed to left, curve is skewed to right. So we assume that, so this is just to reinforce the concept. So right, so we consider this as mean. So the mean will be 0. 1/2 of this curve will be 0.5. The other half is 0.5. So the entire area under the curve is 1. So the mean is 0. The standard deviation is 1. Okay. So that's how we consider that as parameter for a standard normal curve. No confusion, right? So it is option B, standard deviation 1 and mean 0. True. Now let's move on to the next question. Again, we have another similar question pertaining to this normal curve. So which of the following is correct? Mean plus or minus 1 standard deviation covers about 65% of area mean plus or minus 2 standard deviation covers about 95% of area where the z-score is 2, and mean plus or minus 3 standard deviation covers about 99% of the area where the z-score is taken as 2.5. So which of the following statement is true, or are all the statements true? Yeah. So just observe this table in part, it will be clear. They are given the z-score and the corresponding areas. Based on that, you will understand, like mean plus or minus standard deviation 1, what would be the z-score, and mean plus or minus 2 standard deviations, what would be the z-score, right? Because while discussing the standard deviations, I mentioned that 66% of area, 95% of area, and 99% of the area, right? So if you correlate those values with the areas of z-score, then you can easily remember the z-score also, right? So all the given statements are true in this case. Yeah, it's fine. Again, we have another related question. Like in normal distribution curve, mean, median and mode are equal. In positively skewed, that is right skewed distribution, mean is greater than median. In negatively skewed, the reverse is true. Okay, that's all fine. Yeah. Now let's apply this. Okay, let's have this applicative type of question so that it will be easy for you to analyze what is positively skewed and negatively skewed. So let me just type out the question. So even I'll try answering that. In the meantime, you just answer that and let me know. So the question is, in a quiz, the score obtained by 7 students is 10, 10, 10, 70, 40, 20 and 90. So is it a normal kind of distribution, or positively skewed, negatively skewed, or none? So first arrange the entire, all the values in either ascending or descending order as per your convenience. 90, 70, 20. So try solving it. We'll have the answer soon. Okay, you have the answer. Where is Nidhi? She said she had this mathematics in +2. Now, Nidhi, you have the answer. Okay, Sirisha, great. Okay, right. So I hope these are the values which you got. So the median is 20, the mode is 10, the mean is 35, right? So the mean is greater than median and mode, right? If you remember this image, so this one, the mean is greater than median and mode. Yeah, so this is a positive distribution, right? Positively skewed, not positively skewed, positively skewed or right skewed. Positively skewed is also called as right skewed. Bingo. Okay, next we have another question. When a circle is divided into different sectors corresponding to the frequencies of variable in distribution, the diagram is pie diagram, bar diagram, histogram, pictogram. The question: when a circle is divided into different sectors corresponding to the frequencies of a variable in the distribution, the diagram is known as pie, bar, histogram and pictogram. Yeah, so it's obviously pie diagram, right? And pie diagrams are considered as inferior to bar diagrams, as lot much information is hidden or it cannot be represented. Only the frequencies can be represented, that's it. Yeah, now the question, I'll have another question for you. Yeah, in a population, the standard deviation is small, and if a small sample size is taken, then the standard error will be high, it will not be representative of population, it will give precise result, or standard deviation increases. It cannot absolutely say that even though the standard deviation is small and small sample is taken, obviously the sample is taken from the original data, original population, right? So you cannot rule out saying that it is not a representative of population. even though it doesn't represent that 100%, at least there can be some similarities between the sample and from where the sample is taken, that is from the source, right? No, SD is small, that's already given in the question, right? So they already fixed the SD value. If at all they ask you like the relation between the sample size and standard deviation, then you can say small sample size, more standard deviation. But they have said in the question that SD is small, sample size is taken. So look at the other options. What about standard error? Yes, Pritika. Yeah, Nidhi. So what is the relation? So standard error. So as I said previously, when I gave you an example regarding calculation of population, the mean age, if you take small sample, then the probability of error or the difference in the sample mean and the actual mean will be more. If you take a large sample, then the sample we're trying to include more observations, so it will be more representative of the original population or original data, then the standard error will be minimal. So the relation, okay, if you don't understand all that, okay, that's fine. The relation between standard error and sample and standard deviation is given by the formula. You have the formula, right? Standard error is equal to standard deviation divided by root of number of observations. So they are inversely proportional. That's true, Pritika. Yeah. Yes, Nidhi, Sirisha, Pooja. Yeah. So smaller the sample size, greater will be the standard error from mean. Okay. I hope it's clear. Now another question. Yes, Pooja. That's true. So another question, histogram is a type of pie diagram, bar diagram, frequency polygon and line diagram. Histogram is a type of pie, bar, frequency polygon and line diagram. Suresha, you say bar. Preeti, you say bar. Okay, Abhishek and Pooja also say bar. Okay, everyone says bar. Preetika, Nidhi, Megha. So it's a special type of bar diagram. If you remember, the frequency distribution can be represented in form of bar diagram, which is nothing but histogram. And what is the relation? What is the difference between histogram and frequency polygon? Relation between histogram and frequency polygon. No one remembers? I mean, we had that discussion in our virtual classroom. So both histogram and frequency polygon, they represent the frequency distribution. Okay, glad, I'm happy that Sirisha answered. Yes, Megha. Yes, Nidhi. Yeah, when you join the midpoints of histogram blocks, the graph which you obtain is nothing but frequency polygon, right? Okay, fine. Okay, now we'll proceed with the summary, because I feel like we need to briefly summarize in order to minimize confusion and to improve clarity on the concepts, right? So as most of you posed some questions yesterday, so I'll briefly give you the review or the summary of all the questions which we have discussed at the beginning. So regarding the effect of skewness, yeah, is it streaming live? It's showing as poor network. I mean, is it streaming? Can I proceed? I think it is breaking. I mean, just let me know whether it is streaming or not. Yes, streaming. Okay. Okay, Nidhi, I'll get back to your question at the end, right? So I hope it is streaming. Yeah, fine. So as I said, I hope it's clear now, right? Regarding the effect of skew, I think you're having poor network connection. Okay, anyways, I'll just proceed. If in case it is breaking or if it's not streaming, just drop a message, I'll stop. So we have discussed about the effect of skewness on mean, median and mode, right? So I need not really elaborate on that. I have already shown you some images of graphs of skewness, right skewed and left skewed, right? So, and also regarding the differences between standard and mean deviation. So apart from the formula as Sirisha asked us yesterday. So standard deviation, it is a common measure of variability and it helps us to analyze the measure or the amount of spread of given observations, right? So if I say standard deviation 1 or if I say standard deviation 2, so based on that you can have a mental picture like how the observations are being distributed in a given context, right? And also standard deviation can never be negative as we are squaring all the values. We are squaring the deviations and then we are doing the root, right? So squaring is done first, so there can be no scope for negative values. But mean deviation is nothing but it's the amount of deviation that's from the mean value, and mean deviation or average deviation is the average of these deviations. And while calculating these mean deviations, if you observe the table as given in par, they are considering or only the whole values are considered rather than the negative symbols or positive symbols, because as I mentioned, when trying to calculate a deviation, for example in an exam out of 100 marks, if mean value is 90 and if I get 80, then the deviation is -10, right? So I am below that. So mean deviation, they do not consider the symbols, only the absolute values are considered, and it's not commonly used. while calculating the deviation. Only standard deviation is used because as per literature the chances of error are minimal since we are squaring and since we are performing this root, right? So it is less complicated as given in literature, right? So that's pertaining to standard deviation and mean deviation. And in this context we have also discussed regarding whether SD can be positive or negative. So it can never be negative, but Z value, which represents the distance from the mean to one side. For example, in case of a normal curve, if you divide the curve, from the mean, we have left half and right half. Z value gives us the distance from the mean. In the sense, it gives us the number of standard deviations from the mean. So Z value score gives us the number of standard deviations from the mean. It can be either positive or negative. If I say 2, for example, -2, it means Z value, if it is -2, then we are 2 standard deviations away from the mean on the left side, right? So that is Z value. So the range of Z value can be usually -3 to +3. And Z value can have positive and negative values. If it is left side to the mean, then we have this negative value, or below the mean, negative value. Above the mean or right side to the mean, it's positive value. And Z value is given by the formula x minus x bar, that is observed value minus arithmetic mean divided by standard deviation. So that's the way to calculate the Z value, right? And standard error, so as I said, standard error gives us the variability or the difference in the sample mean from the actual mean. So if you're trying to calculate the average age of Indian population, then we cannot count the entire population. We take a representative sample, but the mean of this sample, the arithmetic mean of this sample, and the overall mean or the actual mean will be slightly different. Because the sample is a smaller one, we cannot really try or expect this sample to represent the entire population. But since because of limited resources, etc., we're taking a sample, right? So the actual mean and the sample mean will not always coincide. They might coincide in an idealistic scenario when you count or when your sample size is entire population. So that is idealistic scenario. That's not possible, right? So the difference, to put that simple, the difference between sample mean and the actual mean is given by standard error. Greater the sample size, the minimal the standard error will be. If you still don't get it, just remember standard error SC is given by the formula standard deviation divided by root of number of observations. So greater the number of observations, greater the sample size, lesser the standard error, or smaller the sample or lesser the number of standard observations, than greater the standard error, right? So that's pertaining to standard error. And also I have seen few questions pertaining to these topics which we have discussed. And regarding the question posted by Nidhi, you say coefficient of variation. Coefficient of variation, it's given by standard deviation divided by mean into 100. If you want the practical application of it, I'll refer and I'll get back to you, right? So coefficient of variation is measured by standard deviation divided by mean into 100. So as one of you asked me yesterday, right? So just try to note down all these formulae in one part of your notes, right? Standard error, standard deviation, coefficient of variation, all these values, enter them in a specific area in your notes, memorize them, just memorize them, right? And it's not that they will ask you this formula, but you can have applicative type of questions, right? So don't neglect this. I know this is very dry, this is highly volatile, but still, if you understand the concept, so you just understand the concept, just try to apply that to one particular study. As I said, standard error, if you try to compare that with a simple example like considering the age, the mean age of population, it will be much more interesting, isn't it? Right? So when you have that applicative mode, only then we can proceed with confidence and we can enjoy the subject, or else it will be like hell. Just memorizing this stuff, trying to by heart this, it will be like hell. But when you have this applicative mode, you will enjoy, right? Just take my word. And if you have any queries, don't hesitate to bombard me with questions. You can pose any question pertaining to these topics or any topics, right? You can drop a mail at proudtobedentist@gmail.com. And I've done my best within my capacity to explain you. If If at all you have any problem in my way of approach, or if you're not able to understand anything pertaining to what I've explained, feel free to share that with me. I'll try to simplify that further, right? So also we're doing some recorded videos. Yesterday we have, so far we have done around 3 or 4 recorded videos pertaining to public health dentistry, regarding primary health center, and regarding these ethical principles, communication. So we'll post more recorded videos. We'll do more recorded videos and we'll try posting them in our e-classes as well, right? Glad to hear that, Nidhi, and thank you so much for the feedback. Yes, that's true, Sirisha. Even for me, during my undergraduation, as I said, I had one professor who used to give me these examples. So it will be simple to understand only with examples or explanation. Because simply put, if I say standard error is nothing but standard deviation divided with square root of mean, square root of observations, we'll keep on banging our heads to wall and we'll never understand what this standard error is. Just for example, so any concept in biostatistics, it's so beautiful. This tests of significance, everything, they're so beautiful, provided we need a proper explanation. Only with proper explanation, only with proper correlation with practical scenario, practical test-based scenario or a study-based scenario, we can understand this in a much better manner. Or else, as I said, it's going to be hell. And glad to hear that, Sirisha, and thank you so much for the feedback. Yeah, Sanjay, you're welcome, Sanjay. I'm sorry, Sanjay, you're welcome. So anyways, I'll try to have more videos in a more simplified manner, right? So yesterday, while I was discussing, before concluding the session, I couldn't really put this stuff, the probability, the Z-score and all. So I had to take the pics and I had to project them today. So anyways, if possible, we'll have some discussion pertaining to the topics of biostatistics in specific on both, right? We'll have more recorded lectures, and also because once you have those graphs and all, only then it'll enter into your minds. We need to have that mental picture. So mere theoretical explanation of these concepts is pretty hard to grasp, right? So we'll have more recorded lectures pertaining to these topics, not just this subject, but as many subjects as possible in as shorter duration as possible, because the exams are approaching. We have 3 months time, so this is not to frighten you, but this is to caution you, right? So limited time, so you should be more alert. At the same time, if the stress levels in us are increasing, then it's going to have a negative impact on our preparation, right? So even though we need to be realistic here. Practically speaking, we should realize the fact that we have exams in 3 months or 4 months time, but it doesn't mean that you should feel tense, because as I said, as I spoke for 2 hours regarding the NEET exam pattern and psychometric analysis, remember, this is a comparative exam, like how well I am doing in comparison to your performance, right? So if I'm feeling tense, so obviously it means that I'm going down, because this exam is all about comparative analysis. The better you do compared to your peer or compared to your colleague, the brighter the chances you have to score well. It doesn't mean that you have to deceive them or you have to hide away material from them. No, nothing like that. You should have a healthy competition. And see, ultimately, only when you have this healthy competition, when you have this study club, when you have this positive discussion happening, it not only helps everyone, but it most importantly helps you personally, right? So keep that in mind. Be selfish, right? Be selfish. Share information so that you can learn more, right? So that way you can be selfish, right? So be positive, try to understand the concepts, don't worry about memory, because most often I'm getting few messages this week saying that since exam is approaching, we're feeling tense, like we are trying to forget, or we're forgetting, or we don't know whether we would remember all the stuff which we are reading or not. But that's true. The truth is, you will always remember whatever you study, because you assume, even when I was preparing, or I've seen many personally preparing, they assume that they're not remembering when they're studying. But you know what, the beauty of human brain is that at the time of exam, stress-free conditions, or when you're relaxed and when you're confident and positive, everything comes to your mind. Take my word. If you want, I can sign on some document also now itself. Take my word. If you're cool, if you're positive, if you're confident, right, then obviously whatever you studied will come to your brain, will come to your mind. There is no doubt in it. So be confident, just put your effort, just make sure that you give your 100%, just pay focus, pay attention to what you're going. You just randomly read or randomly go through these formulae and all, you'll never remember, right? So try to understand the concept. For example, understanding the concept, memorizing them, and then leave. When you revise later, of course, revision helps in establishing the concept in your mind over and over again, right? So revision is very important, so that's going to play a key role, and we'll have a separate video regarding how to revise and various tips pertaining to revision. Don't worry about that, but believe in yourself. Whatever you study, you're going to remember that till the exam, at least till exam. I can't guarantee you whether you can remember that for a lifetime, but at least till exam, you are going to have that in your mind, right? So be confident, don't worry, do your best, and leave the rest. Okay, glad to hear that, Nidhi, and thank you so much for your feedback, and thanks for your love and affection as well. Right, so we'll conclude the session. It's already 6:30, so it's 80 minutes, 1 or 20 minutes. I hope I've clarified your queries, and if in case you have any further queries, Bernice, I'll go through your query today, and I'm not sure whether Bernice is online or not. I don't think so. Okay, so any queries, I'll just drop a mail. I'll reply as soon as possible, right? And once again, it's really great to see, because public health dentistry, it's like many people fear for it, but still you people are live and you're bearing my lecture. It shows that you're really interested. Okay, fine. So we'll conclude then. So have a great day and take care, right? All the best.